In this chapter, we're going to study trigonometry. In this lesson, we're going to introduce you to the cosine law and use it to find the missing sides.
Okay, hey everybody. So in this lesson here, we're going to look at something called the cosine law, and we're going to use the cosine law specifically to find a side of a triangle that's missing. Okay, so now usually at this point here, because we've gone through the sine law, we look at the cosine law, the question is there a tangent law? And the answer is no. No, it's just the sine law and the cosine law. So in this particular case here, once again, this really works well for triangles that aren't right-angled triangles, okay? But it also works for a very specific set of information here. And what I want to do is I want to just quickly show you here. These are three different ways that we can use the cosine law to find a side. So we would use this one to find side A, this one to find side B, this one to find side C. And it's the same pattern, okay, of variables every time. It's just that which one do you know, and you didn't just use the other two here. So if I'm looking for side A, I'm going to use B and C in these two spots here. If I'm looking for side B, I'm going to use A and C in these two spots here, right? If I'm looking for side C, I'm going to use A and B in these spots here. And then whatever side you're looking for, you're going to end this with the cosine of the angle that's on the other side there, right? So looking for little a, I use the cosine of angle A. Little b, cosine of angle B. Little c, cosine of angle C. And that's the cosine law. Now, it is a little bit more complicated than the sine law, okay? But it once you get used to it, it's not so bad here. And it is interesting to note here that if I just cover up all of that, okay, that what you're looking at here, you probably recognize that as the Pythagorean theorem. And yeah, it is. What we're seeing right here really is just an extension or an adaptation of the Pythagorean theorem. Now, so that you know, before you can use this, in the sine law, to use the sine law, you had to have an angle and the side opposite it. But in this case, you don't. If I want to use this, the cosine law to find A, then I need these three bits of information to find A. If I want to use the cosine law to find C, then I need these three bits of information to find C. And if I want to use the cosine law to find angle B, side B, then I need these three bits of information to find B. Now, my diagram is looking kind of complicated at this point here, but I need side, angle, side to find the side opposite the angle. So I need the two sides here, the angle in between, and boom, that helps me find the side on the other side of the triangle. Anyway, let's take a look at some questions to make sure that you understand how this works. Okay, so we're going to use the cosine law to find the missing sides in these next few questions here. So take a look at this one right here. I have got side C, okay, it's opposite the angle C. I've got angle A, and I've got side B here. So what I want to do is I want to find side A, the one that's missing here. Okay, so I know that A squared is going to equal B squared, so it's going to be 9.9 squared plus C squared, 8.4 squared, minus 2 times B times C times the cosine of the angle in between. Now, for the first few times that you do this, I suspect you're going to need to have that equation handy so that you can just follow along here. But soon you'll get used to the pattern here that if I'm looking for A, okay, it's going to be the squares of the two sides that I'm given added together. Then I'm going to subtract 2 times the two sides multiplied together, multiplied by the cosine of the angle. Now, I'm going to go through and get that. Okay, so that's going to be 9.9 squared plus 8.4 squared, 0.4 squared, minus 2 times 9.9 times 8.4 multiplied by the cosine of the angle in between. Now, notice that I'm doing this all in one step here. Frequently, people will get this wrong because they try to break this up into pieces, like they'll do the sum of the squares, they'll do the product, and then for some reason they then multiply by the cosine at the end. But if you break this up into steps and do it like that with the calculator thinks that you're multiplying the cosine by that whole answer, and you typically get a wrong result here. You're far better off doing it all in one step in your calculator like this. I press enter and I get 73.2 when I round that. So this is going to be 73.2. Now, when I look at my triangle here, whoops, that doesn't make any sense. 8.4, 9.9, 73.2? Oh, because, sorry, this is a squared. So to get the a, I need to take the square root of that. So this is, again, like the Pythagorean theorem. I need to end this with a square root of the answer I just came up with. And here I'm getting 8.6. Okay, that's the value that I'm looking for. And that makes sense. That is far more reasonable. Okay, let's take a look at another one. Whoops. So this one right here, I'm looking for little r. I've got little q, and I've got little p. Okay? So now I know that my equation here is going to be, if I want r squared, little r squared. Now, I don't have a formula for this. If you look back at the previous page here, my formulas are all for a, b, and c. Well, what happens if I've got them labeled differently? Well, it doesn't really matter. Here, I put the two sides independently, so it's going to be 4.3 squared plus 6.5 squared minus 2 times, then I do these two sides separately, multiplied together, and then multiplied by the cosine of the angle in between. Okay, so it's just, this is the side that I'm looking for, so it's those two sides that I have squared, added together, minus 2 times the product of the two sides, and then that is multiplied by that cosine of the angle. So now, just like before, I go to my calculator. Whoops, I'm getting a weird glare there. I want to be able to see that. Yikes. There we go. So that is going to be 4.3 squared. Oh, you can't see that now. Ugh, there's no way to win. 4.3 squared plus 6.5 squared minus 2 times 4.3 times 6.5 multiplied by the cosine of the angle in between, 61. And now I get this 33.6. And again, that seems way out of whack there, but it's because I need to take the square root of that. And when you take the square root of, whoops, oh, what did I do? When you take the, oh, sorry, wrong one. Square root of that answer, 5.8 kilometers. And that makes way more sense. Okay, let's look at one more. Okay, same sort of thing. This time, actually, I've got no labels there. Okay, none at all. All I have is this x right here, but it is opposite the angle, and I've got that pattern set up that I was looking at before. So I know that x squared here is going to equal just the squares of those two sides added together minus 2 times the two sides, we're going to run off the screen here, multiplied together, multiplied by the cosine of the angle in between. So now, let's do that. Okay, that's going to be 65 squared plus 65 squared minus 2 times 65 multiplied by the cosine of the angle in between. And I get this, I get this big number. Okay, so this is equal to 5,559.9. Yikes, way too big. That's because I need to find the square root of that. Okay, and so that's easy enough. We just enter that in, the square root of my last answer, and I get 74.6. So x is equal to 74.6. And that is nicely within keeping of the sides and whatnot that we're seeing right there. So that makes sense. Okay, so this problem we read that Lucas and Thomas go hiking through a park. They both leave from the same spot, but Lucas follows one trail, walking 4.3 kilometers in a direction, 40 degrees east of north. Thomas follows a different trail, walking 4.8 kilometers an hour in a direction 52 degrees east of south. Okay, so let's say that this is where they start. We got to get a kind of a visual on this. Let's say that this is where they start. Okay, and so here's my north, south, east, west. And what we just heard, and I'll use different colors for these guys here. What we just heard here is that Lucas follows one trail, walking 4.3 kilometers an hour, 40 degrees east of north here. So 40 degrees east of north means if I point north, I'm going to rotate 40 degrees towards the east. So this is going to be 40 degrees right there. Thomas follows a different path, and we read that his path is going to put him, he's going 4.8 kilometers an hour in a direction 52 degrees east of south. So now east of south means I start on south and I rotate 52 degrees towards south. Towards east. So that's going to go like this, where this angle here is going to be 52 degrees. I want to know how far apart they are after 2 hours. Okay, after 2 hours means that this is going to go on, well, a fair bit longer, so will this. If Lucas goes 4.3 kilometers an hour for 2 hours, let's multiply that by 2. He's gone 8.6 kilometers. If Thomas goes 4.8 kilometers an hour for 2 hours, okay, well 48 multiplied by 2 is going to be 96. Oh, sorry, 96, 9.6 kilometers. Okay, and what I want is how far apart they are. We'll call that x. Well, okay, that's awesome. But what I'm missing is this angle in between. Okay, I know what the angle is out here. I know what the angle is out here. I don't know what the angle is in between. But what I do know is that from north all the way down to south is going to be 180 degrees. So 180 degrees minus the 40 degrees that I've got at the top there that's not in the triangle, minus the 52 degrees that I've got down here that's not inside the triangle, that should leave me with what's left in the triangle. So let's clear up that and go 180 minus 40 minus 52. Okay, whoops, you can't see that. We get 88. So inside here, we know that this angle here must be 88 degrees. Well, now I've got everything I need. Okay, I have got the two distances and I've got the angle in between. So now I can set it up here. I want to find x. So it's going to be x squared. This is totally the cosine law because I don't have an angle and the side opposite it. Okay, I don't know any of that. So this is going to be 8.6 squared plus 9.6 squared minus 2 times 8.6 times 9.6 times the cosine of 88, the angle in between. And so x squared is going to equal, okay, that's going to equal 8.6 squared plus 9.6 squared minus 2 times 8.6 times 9.6 times, whoops, not divided by, times the cosine, the angle in between. And we get 160.4. Except that I got to take the square root of that. Okay, I got to take the square root of that answer. And we get 12.7. 12.7 kilometers. And that does make sense, okay? That is within keeping, within kind of the realm of possibility given the length of those two sides here. So there you go.